This is the first screencast for our new topic, surface area and volume. And chapter 6 starts off pretty straightforward, I think, with a review of prisms and cylinders. So if you were switched on last year, you'll probably be pretty up to date. But nevertheless, for today's work, we are going to go through the stuff on prisms and cylinders, and hopefully you'll find it pretty straightforward. First of all, a polyhedron. This is a screenshot from your textbook, so you can read along there if you like. A polyhedron is a solid bounded by polygons called faces. All right, there's nothing in that sentence that you didn't already know. We're just suggesting that a solid, in this case, all of the faces are in itself polygons, okay? Two adjacent faces meet at an edge, and two adjacent edges meet at a vertex. So I think if I were to use the language edge and vertex referring to a solid, you'd be pretty comfortable in knowing what I mean by that. This is important. A prism is a polyhedron that has two congruent and parallel faces, and all its remaining faces are parallelograms. All right? Now, if I take you down to, say, this diagram here, okay, that is a prism because there's something called a cross-section, which we'll touch on later, whereas if I were to slice the solid through in a direction, imagine I just sliced it horizontally through that way, the cross-section, the shape that was exposed, is a rectangle. And that would also be the same over here, but the section that would be exposed would be a triangle. All right? Now, most of the ones we deal with are going to be called right prisms like this, okay, where it's kind of directly up and the height of it, if you like, is perpendicular to the base of the face. All right? Over here, this is called an oblique rectangular prism, and just understand the language there, oblique and right. Okay, but I think most of it is pretty straightforward. Here we've got a right triangular prism. It's right because the height of it is perpendicular to the base, and also it's a triangular prism because that cross-section that I was talking about, if you slice through, it will actually be a triangle. Okay, so as it says here, when we refer to a prism, we generally mean a right prism. Okay, so that's kind of an assumption that we're going to make a lot of the time. And this is what I was talking about with the cross-section, okay? This prism, as it stands, it's got a cross-section here, which means if you slice it horizontally, we've got an exposed shape, and that's actually the same as the shape up the top, and it's the same as the shape down the bottom, all right? That's what makes it a prism by definition, okay? So we're going to start off looking at surface area of prisms, and probably the main thing to consider is that a surface area of a prism, it just means to add up all of the faces. All right, so if I go back up to this guy here, if I look at all of the faces on it, well, I've got a face up the top, and that's going to be the same as the face down the bottom. Whoop, didn't work out too well for me. It's going to be the same as the face down the bottom. Okay, and I've got a face down the side here, might use a different color. That's going to be the same as the opposite face. And lastly, I've got a face at the very front here, and that's going to be the same as the face at the back. All right, so I know that's a very, very messy diagram now, but you get the idea. We just want to make sure that when we evaluate the surface area of a prism, that we are actually using, we're taking into account all of the faces. Also take note of the abbreviations. We're going to use S for surface area, and we're going to use V for volume. All right, so let's jump into an example. Find the surface area of, well, our first one here, again, it's a rectangular prism. I'm going to have 6 faces. So the surface area, which we're calling S, I might start off by saying, well, that's going to be 2 lots of this face here. So 2 lots of 3 times 5. All right, so that's this face and this face done. I'll now do the front face, which is 3 by 8. All right, so that face there, I want 2 of those. And lastly, I want the very, very top, so this one here, and the bottom, which is going to be the same as it, and that's going to be 5 by 8. And again, I've got 2 lots of those. All right. Now you notice here, mathematically, these brackets, there and there, they don't do anything here, right? But it just demonstrates, I'm just showing my working out by saying I've got 2 lots of that rectangle, 2 lots of that rectangle, and 2 lots of that one. Okay? So we can jump through and we can evaluate all of this. That's 2 times 15, so that's 30 plus 48 plus 80, if I can add up properly. So when the dust settles on that, that becomes 158, I think. 158, and it is a surface area, so my units are going to be meters squared. All right, so pretty straightforward, I think. Just make sure you're showing this as setting out. Okay, I definitely am interested in seeing this as a first step. All right, I want to see all of your calculations there. Notice as well, I've done it all in one line. I didn't split it up into, this calculation and then this calculation and this calculation. All right, so it's probably a good habit to get into. Moving on, surface area of this guy, we've got a triangular prism here. First thing I'm going to do is I'll deal with the triangular face. So the area of a triangle is a half times the base times the height. In this situation, the base will be 3, the height will be 4. So our surface area, and you can see I've got one of these triangles here and one at the back as well. So I want 2 lots of a half times the base times the height. Okay? I've now got 3 other faces to deal with. There's the one down the bottom here. Okay, that is 3 by 6. I've only got one of those. I've got the one at the back, this one. Okay, that's 4 by 6. And the last one is the biggest face here, this one. All right, and that is 5 by 6. Okay, so you might notice here, of course you can just go ahead and use your calculator if you want, but I might notice here a 2 times a half, that's going to cancel out. So I've got 12 plus 18 plus 24 plus 30, and what's that? 84, I believe, 84. And in this case, we've got centimeters squared. Okay, very good. Moving on, cylinder. Now, you'll notice this chapter, it's called a Review of Prisms and Cylinders. And for the most part, we treat a cylinder really exactly the same as a prism. Because if we define a prism to be a solid so that if I were to cut it, say horizontally in this case, the cross-section that I'd end up with would actually become a circle. Okay, so it kind of fits the definition of a prism anyway. All right, so if we want the surface area of the cylinder, we want to consider that, well, it's going to have, if I would stretch it all out and turn it into a net, it's going to have a circle at the top. That's going to be radius r. It'll have another circle down the bottom, all right, accounting for the bottom and the top. And if I were to kind of unravel, all right, so I'll cut this around here and imagine I'm stretching it all the way around and unraveling this curved section. Okay, what I'm going to get is some type of rectangle. All right, now this bit's a little bit tricky. You can probably see the radius was r, but we can certainly see that the height h is going to apply to this length here. Okay, so I might put that in, there's h. And the other thing to consider is, well, what's this length going to be? Well, if you look very carefully, this length, the width of that rectangle, that's going to represent the circumference of the circle at the top of the cylinder. Okay, so given that the radius is r, the circumference of the circle will be 2 pi r. So that's going to give me the length here, 2 pi r. So that's the width of the rectangle there. Okay, so the surface area of a cylinder is going to be, well, this circle will have area pi r squared. This will be pi r squared. So I've got 2 pi r squared. And the area of my big rectangle here, that's going to be 2 pi r times h. So that's 2 pi r h. All right, now you might remember that from last year, but that is the formula that we're going to be using for the surface area of a cylinder. All right. Now, you probably don't want to remember this as just, oh, this is another formula that I'm going to use for maths and whatever. Like, you really want to acknowledge that that is 2 lots of the circular top and the bottom, all right? And that is the curved surface area, okay? So you really need to understand what each of those components are. You don't just want to, regurgitate it whenever you need it, okay? Because sometimes you might have, say, an open cylinder, meaning it doesn't have a top or a bottom, in which case you'd only need this part here, all right? So let's jump into a problem. Find the surface area of a cylinder with a height of 3 meters and a diameter of 4 meters. Okay, so I might just draw this thing. You don't really need to draw it, but I'm going to anyway. Bit dodgy. So it's 3 meters and 4 meters. And the one thing that I'm going to mention here is the formula we just came up with. That was a formula involving the radius and the height. In this problem, I didn't give you the radius. I gave you the diameter. So you really need to just make a mental note straight away that the radius is 2 meters. All right. Apart from that, this is all very straightforward. The surface area is going to be 2 pi r squared plus 2 pi r h. That's 2 pi times 2 squared, because the radius was 2, plus 2 pi times 2 times 3. And from that, I don't want you to pull out your calculator straight away. Right? A good habit to get into is to evaluate all of this first. So 2 times 2 squared, that's 2 times 4, so that's 8 pi. And over here, 2 times 2 times 3, that works out to be 12. So that's 12 pi. So you can collect like terms there, and you've got 20 pi. But it did ask for it in 2 decimal places. Sometimes a question will say, give your answer in terms of pi, in which case you just leave it in that form, okay? But it wants it in 2 decimal places. So I'm just going to use my calculator now to type in 20 times pi, and that's going to give me approximately equal to 62.83, and my units are going to be meters squared. Right, very good. With volume, again, volume of a prism and volume of a cylinder are very similar, okay? I've poached a diagram from the textbook here, and it's a good one to think about. The volume of a prism, you need 2 pieces of information. You need the area of the base and you need the height. And it really is as simple as this. The volume is going to be the area of the base multiplied by the perpendicular height. Okay? So that comes, you can think about why that's the case. Really, if you're not sure why that actually works, it's probably better to go back and think about some rectangular prisms and build up from there, all right? But for now, that's pretty much all I'm going to give you on that. For a cylinder, down the bottom here, it is actually the same formula, okay? But we just might call that our A. But it is certainly true that the volume of that thing will be A times H. But we can do a little bit more with it because we know that this A, that's a circle, all right? The cross-sectional area there is the area of a circle, and the area of that circle is going to be pi r squared. So we can actually be a little bit more specific when we're talking about a cylinder and say the volume is pi r squared h. All right, so when it comes to finding volumes, these are the 2 things we're going to be looking at. All right, for now anyway. It's going to get a little bit more complicated later on, but for prisms and cylinders, these are the ones we want. So I've got 2 examples here. All right, calculate the volume of each solid. So, this is a triangular prism. Okay, you can see if I were to cut the prism kind of somewhere along that direction, I'm going to get a cross section that's going to be congruent all the way through. All right, and that's going to be a triangle. All right, so what we want to do is just say, well, okay, if I can get the area of this triangle and multiply it through by the height, that's going to be it. All right, so that's the main thing to consider. We want to make sure that we understand that the cross-sectional area multiplied by the height, or in this case, it's kind of like the depth, will give us the volume, okay? And often the hardest thing with these problems is actually deciding what face am I going to look at. But you want to think, well, it's a prism, so we want the face that is congruent all the way through, okay? So I might jot down first the area that I'm after, which is going to be the area of this face. That's a half times the base times the height, which is 4 times 3, that's 12 centimeters squared. Therefore, our volume is going to be 12, well, remember we said it was A times H, so that's 12 times 7, and that's going to be 84. And our units in this case are going to be centimeters cubed. All right, pretty straightforward. For our second example here, we've got a half cylinder, all right? And think to yourself, what is the cross-sectional area that I want to think about? What is the shape that's going to be congruent all the way through? And the answer is, it's going to be a semicircle. Okay, so if I can take the area of that semicircle and multiply it through by the depth, that's going to give me the volume that I'm after. Okay, so what I might do here, I'll call that A for semicircle, A for the area of the semicircle, I should say. So the area, it's going to be a half of pi r squared, because it's half of a circle, all right? And the radius in this case is going to be 4. Again, I've given you the diameter there. You've got to think about these things. So area is a half times pi times 4 squared. That's a half times pi times 16. And I'm just going to leave that as 8 pi. And that would be centimeters squared. All right. There's no reason for me to type that in a calculator. As a matter of fact, it's probably a bad idea, because what can happen sometimes is if you use a calculator too early on and then you round that answer and then use it, you can mess up your decimals. Okay. So the last thing I want to do here is calculate the final volume. That's going to be A times H, which is 8 pi times the height, which we said was 10. And that's going to be 80 pi centimeters squared. If I did want to round that, I might do that to 2 decimal places here. Just very quickly, 80 times pi, that'll work out to be 251.33 centimeters. I said squared here, didn't I? That was a bit silly. Centimeters cubed. Okay, so that's pretty much it. The main thing I want to emphasize here before I finish up, show some working. Show some working. I do not want to see your working and just see, one number on the page. Okay? Remember, if you are going to use your calculator, the golden rule with using a calculator, do not type anything into your calculator that is not written on your page. Okay? So I'm expecting to see lines like this. I'm expecting to see lines like this. Okay? So we'll finish up there. It's a pretty, I think, easy start to the topic, but that should keep you busy for a while. There's a pretty good exercise on this stuff. So we'll finish up there.